Okay, the next problem I'd like to show you is how to graph the function y equals 1/2 the secant of 3x. Now, it's critical here that we remember the secant is 1 over the cosine. So secant of 3x is 1 over the cosine of 3x, and of course this whole thing is being multiplied by 1/2. Now that alone is enough to give us a general sense of what this looks like, because we can ask our calculator. 1/2 over the cosine of 3x. If we were to graph that on a standard trig window, you get something like this. So you have these kind of U-shaped functions, and you can see that half of them go up, half of them go down, and they're staggered. So this one goes up, the next one down, the next one up, etc. So where does that come from? Well, the cosine function itself, here's a basic period of the cosine function from 0 to 2 pi, starts at 1, swoops down to -1, back up. Notice at pi over 2 and 3 pi over 2 you have zeros. Now, you cannot divide by 0. So if you have a function that's composed of a fraction, and that fraction occasionally has a 0 occurring in the denominator, you expect something interesting to happen in the graph. And what happens in a case like this is that you get vertical asymptotes. So everywhere the cosine is equal to 0, those are the odd multiples of pi over 2, then the cosecant will have a vertical asymptote, or rather the secant is what we're working on. The secant will have vertical asymptote. So notice pi over 2, we have a vertical asymptote, 3 pi over 2, another one. And so you get these U-shaped functions in here that fit within the envelopes created by these vertical asymptotes. Now, there's actually some good, if you need some help with getting from here to here, there's actually a very good video available on YouTube, and I'm sure many other places as well. So poke around a little bit and get some more detail there. I will try to remember to post a link to one of them in the Blackboard course, which will get you started if you need that extra help. But what we want to do is actually translate that to secant of 3x, and with this coefficient of 1/2 here. So what I'm going to do is take a basic cosine curve, looks sort of like this, and I did not label these because I've got a coefficient in here on the x, and that's going to shift things. Notice this cosine, I'm not looking at the whole thing right now, I'm just looking at the cosine. The cosine does not have a phase shift on it, so that first point is not going to get shifted left or right, but this will get compressed because we're multiplying by 3. So the period of the cosine x, has period 2 pi, and the cosine of 3x then has a period of 2 pi over 3. Simply divide by this coefficient right here. So 2 pi over 3 is the full period, and what that means is for the cosine that our secant function is going to be based on, it starts at 1 here, and then it comes back up to 1 again at 2 pi over 3. Okay, now if that's 2 pi over 3, then dividing that in half, pi over 3 is where this particular cosine, the cosine of 3x, where that is going to have a minimum, and then half of that, pi over 6, and pi over 6 to the right of this is 2 pi over 6, plus pi over 6, 3 pi over 6, which is pi over 2, is the x-coordinate of that vertical asymptote. Now, if you wanted the one back here, you could get it pretty easily. Since this distance is pi over 6, that one must be as well. So this must be minus pi over 6. And we get another vertical asymptote in our secant graph. Okay, now with the standard cosine function, this height would be 1. But remember, when we get all done here, we're going to be multiplying by a factor of 1/2. So when the cosine would normally be 1, well, you could think of it as 1 over the 2 times the cosine, which I think is not that helpful. It would grow up to 2, but then the reciprocal of 2 is 1/2. Or you could think of this. The cosine maxes out at 1. Its reciprocal then will have a minimum of 1, and then you multiply that by 1/2. So it's just half that height, and these are going to shoot up like this. Now, it's these U-shaped pieces, so this will be at height minus 1/2. These U-shaped pieces are the secant function, not this snake-shaped thing here. So let me just lighten that up a little bit. I try not to obliterate it entirely, because it's kind of a helpful guide to drawing. But it's these U-shaped pieces that are our secant graph. And if it were not for the 1/2 here, then this would have a height of 1, this would have a height of minus 1, but everything's been halved. So this is at 1/2. So the coordinates of that point right there are 2 pi over 3. And then the height is 1/2. The coordinates of that point right there, the x-coordinate is pi over 3, and the y-coordinate is minus 1/2. And the x-coordinates anywhere on this vertical asymptote are pi over 2. On this one, they are pi over 6. And this one we could compute as well. We have a distance from here to here is pi over 6, so 2 pi over 3 plus pi over 6 would be the x-coordinates for this asymptote here. So the equation of that line is x equals this value. Well, multiply up and down by 2. 4 pi over 6 plus pi over 6 makes 5 pi over 6. So 5 pi over 6 there. Now, let's just kind of confirm that with our calculator. First of all, let's get back to the main window. How about if we check out this 5 pi over 6? So we're looking for about 2.617 and a couple of 9s. 2.617, a couple of 9s. Take a look here. I want to trace this. So I'm going to use my trace button here. And I am looking for, it's the upside of that, this guy right here. And you can see we're starting to get close to that, almost 2.5 here. And of course, it's going to go off the scale quickly because this function grows so quickly. But around 2.6 is what we had, and 2.617 is the exact location of the vertical asymptote there. So things are being pretty well confirmed, and we could do more of those calculations, but we're getting what we expected. So that's the graph of 1/2 the secant of 3x.